Welcome to the e-learning platform series by Science Park. The topic which I am going to cover today is force and pressure. This is the part 3 of force and pressure. In the previous parts, we have learned about force, the types of force, the effects of force, and then we have seen about pressure. The pressure exerted by liquids and gases as well. So the subtopics that we are going to cover today are, we are going to learn about atmospheric pressure, the magnitude or the value of the atmospheric pressure, the variation in atmospheric pressure as we go to different altitudes or different heights, and then we'll see an interesting experiment on atmospheric pressure which we can all do at our home very easily. So let's start now. So to begin with, we will learn about atmospheric pressure, or exactly what is atmospheric pressure. So you know that our earth is surrounded by a layer of gas which is called as atmosphere, and that layer of gas is attracted towards the earth due to the gravitational force. As you all know that air consists of tiny molecules or atoms, so they are attracted towards the earth. So naturally, when they are attracted towards the earth, they put some pressure on earth. Yes, and that pressure is nothing but the atmospheric pressure. Yes. When you fill the balloon with air, when you inflate it, it also puts pressure on the walls of the balloon. Similarly, the air around the surface of the earth, it puts pressure on the surface of the earth, and that is called as atmospheric pressure. Right. So, well, we have learned about the unit of pressure, that is Pascal. So let's see what is the value or the magnitude of atmospheric pressure. Oh, quite a nice picture that. But I am thinking, what is the significance of this picture here? Why I am showing you this picture? You see the sea in this picture, right? Yes. So this is called as sea level. Yes. Now, my dear friends, whenever you measure something, you measure it with a reference level, right? So this is called as a reference level for Earth for measuring various things such as altitude. Yes, so altitude is considered 0 at sea level, right? So this is called as sea level. And the air pressure here at sea level is 1 atmosphere pressure, right? It is called as 1 atmosphere pressure. Wait. But in the last video, we saw that the unit of pressure is Pascal. Then when did this 1 atmosphere pressure come up from? Well, this is another unit for pressure, specifically to measure the atmospheric pressure. Now let's see what is the relation between Pascal and atmosphere pressure. So 1 atmosphere is equal to 101 into 10 to the power 3 pascals, or 101 kilopascals. That is the pressure exerted by air at sea level. That is also called as 1 bar of pressure. Kilopascals, that is too huge. Yes. Now let me ask you a question. Now we know that we are all surrounded by air which exerts some pressure on us. So if we are going to calculate the weight of that air just above our head, do you know what is the weight of all the molecules of the air combined on the top of your head? Well, the answer to that, oh, that's 1 ton of air. Oh, a lot of weight on us. Oh my God. Do you know the weight of a small car is actually equal to 1 ton? So that much amount of weight is on us. Oh my God. Just imagine a small car on top of your head. You'll get crushed. But are we? No. Well, this air which is around us, that exerts pressure in all directions. Yes. So as well as pushing us down, it also pushes up and balances out the forces on our bodies so that we don't collapse. Human bodies are actually used to this air pressure. You know why? Because the air pressure in our body, such as in our lungs, in our stomach, in our ear, is the same as the air pressure outside our body. And that is exactly what ensures that we don't get collapse. Right. Now we will have a look at the variation in atmospheric pressure. Now this variation of atmospheric pressure is with respect to altitude. So as we have seen, the atmospheric pressure at sea level is 101 kilopascals. So if we have a look at this graph, on the left side, that is on the y-axis, we have the total pressure, and on the x-axis we have altitude in meters. So at sea level the altitude is 0. So the corresponding pressure at 0 is around 100. Yes, and that is 101 kilopascals. Yes. So as we gradually move upwards from sea level, the altitude will increase. And as the altitude increases, we see that the pressure decreases. Yes. You see a sudden fall in the atmospheric pressure as we go up and up above the sea level. Now why is it so? It is because the air molecules get less dense as we go up above from the surface of the earth. And there are less air molecules to put pressure on us. That is the exact reason why the air pressure decreases, or why the atmospheric pressure decreases with increase in altitude. So if we go at the top of Mount Everest, we suffer from, there is very less amount of air, so it's very hard to breathe in. So we need an external agent such as an oxygen cylinder with us to breathe. Well, we'll have a look at an interesting experiment now on atmospheric pressure, which we can all do at our home. So have a look at it. So in this experiment, I am going to show you the application of atmospheric pressure. I have with me a glass full of water and a piece of cardboard. Now I am going to keep this piece of cardboard on top of this glass. Now my question to you is, what if I flip this glass over? Will the water fall down? Let's see. I'm going to flip this glass upside down and I'm going to leave this hand. Oh, the water doesn't fall down. Now why is it so? There must be something which is pushing this cardboard up. What is that? That is atmospheric pressure. Now, the atmospheric pressure must be more than the weight of the water inside this glass. So that experiment was nothing but magic. Yes. So let's summarize what we have learned in this video. So first we have learned about the atmospheric pressure. The value of atmospheric pressure, that is 101 kilopascals at sea level. The variation of atmospheric pressure as we go up about from the sea level, and we have seen that it decreases. And we have seen the experiment with glass and card sheet. Now that experiment we can actually do at our home, which is very simple. Now at the end, we have a few questions to tease your brain. So you can pause the video, you can find the answers, you can write them, you can mail it to us, or you can write it in the comments below. Yes, so thank you. See you in the next video.